Kelvin Lu, self-proclaimed Navy SEAL, machine learning engineer. I guess, yeah, tell us a little bit about your journey.
Yeah, many years ago, I was a very happy Java developer. I spent most of the time to learn the JVM, how the Java compiler works, and the subtle detail of all the data structures.
Yeah, right. Okay.
Yeah. And then all of a sudden, I realized that actually the big data and the machine learning is really driving the future. So I spent two years to prepare myself for those kind of new challenge.
Yeah, right.
It's about 6 years ago, I got my first commercial experience with big data and the machine learning. The company called MData to build a machine learning feature management platform. Yeah, that's my first experience.
So really you kind of, I mean, it's interesting, right? Because we were talking about before, your experience in that big data ML space, and where we are now, we've seen like a few waves of technology, right? I guess, when you're looking back at some of your experience, at Macquarie and NAB and those kind of places, NBN as well, here in Australia, right? I guess, I remember, probably 10 years ago, between that 5 and 10 years ago, market was just, even just doing big data statistics was kind of a new thing, right? There were a lot of opportunities in that space, but I guess we talked a little bit about, the waves of an explosion now and to where we are now with computer vision, or not so much computer vision, but just general AI in general, right, has come a long way. So I guess how have you, I mean, particularly I guess you got drawn into that, but I mean, what has it been like from your perspective, like going into each of these companies and seeing how they've had to adapt and adopt to these new technologies as well?
Well, I think for Australia, I think we are not leading the application of big data and machine learning. Actually, over that time when I started to find opportunities, the opportunity is very rare, actually.
Yes, in Australia, I agree. It's interesting, right? Yeah, definitely. Yeah.
But I think patience will really pay off. So after you have continuously prepare yourself and seek opportunity and prove your value to the business, and eventually you'll get on the right track.
Yeah, definitely. And I guess looking at where the state of AI is now, I guess what are you excited about? Say where, there was kind of there's been a few kind of bubbles of AI, right, in the last kind of, I would say 30 years, right? When things, autonomous machines and different things like that. And then there was the kind of computer vision with CNNs. That's what when we started at Tiliter, we were kind of focused on that. What are you excited about now? What do you think is interesting about this space and this time at the moment? Has anything changed, or is it still like companies still trying to catch up to that wave of technology?
Actually, I think especially for the recent 2 years, the machine learning field is getting more and more exciting. I think the most interesting thing is the development of the generative AI, large language model, and especially the marriage of large language model with the traditional computer vision. I think that's really appealing.
Yeah, it's interesting to say, like, I guess the marriage of those things. What do you see? That's an interesting topic as well, because I guess there's a lot of excitement at the moment about what's possible with the Gen AI tools. But yeah, maybe dive into that a bit more. Like, what do you mean by that marrying of the Gen AI space and the traditional computer vision space? What's your feeling there?
I think the two services just released by OpenAI is very good examples. First one is the Sora. Sora is the model for generate the short videos. Yeah, actually, those technology was purely based on the transformer.
Yes,
the large language model technology applied to vision, but it's not on the single static image. It's on multiple frames and build the video based on the frames.
Yeah, that's right. And I guess at this moment, we're really at the cusp, right? Because Sora is not public, and we're just seeing some of the things that are possible with it. right? And it's been interesting. I mean, I would say for us in this computer vision space, because I've been watching the, I guess, LLM space for the last sort of 2 years since ChatGPT, right? I think every engineer, as soon as they use ChatGPT, this is not news. They were like, oh, wow, this is a bit of a breakthrough, right? It's kind of gone forward, leaps and bounds in the chat space. But, I would say in the last kind of getting on, 2 to 3 months now, you're starting to see obviously the APIs available for vision with GPT, with Google Gemini, even Anthropic having vision capabilities. And that was something I think that, we're all kind of waiting for. Like you could post images into ChatGPT, but you couldn't actually do it programmatically, right? So for us as a company in that computer vision space, we're definitely seeing, I guess, opportunities there, right? But challenges as well. There's still a long way to go, but I think I've said a few times to the team, my feeling is on this space, the egg is cracked, right? It was kind of like when we first started using chat. It felt like, breakthrough moment. It feels like that with vision, right? Compared to what we could do. I mean, CNNs, it was interesting though. And that's where I think, is it just going to be the same story again? We'll see. Because everyone said the same thing about CNNs, if you remember, right? When it came to, it was like, it's going to do everything. And then all of a sudden now the transformer world is, sort of, taking the mantle in terms of the thing that's going to solve it all. So, I mean, that's where I'm interested. I mean, you've been in the game for a while. Like, I'm interested to sort of, learn from your experience as well. Like, is that what you're feeling at the moment? Seeing the trends, versus this time and what we can see with AI tools versus, everyone was talking about, doing great things with CNNs back when they first came out as well. So what's your feeling on that versus, the then versus now sort of situation?
Yeah, actually, for traditional computer vision, it's purely based on the CNN. It just scan through all the image, and do the processing. And now with the transformer, it's trying to understand the connection between all of the patterns. And another recently released service from OpenAI called Chat for All. Yeah, that's really a very. I think it's more important than Sora.
Because in what sense? That's interesting.
Because traditionally, when the transformer works, it follows the way of regressor. That means it has to predict one token and then the next, and then the next follow. So that's why it's very slow.
Yes.
Yeah, it's very slow. And for the chat for all, you can see it's very fast. And also OpenAI promised to offer the service for free. That means they find a way to parallel the service very cheaply.
Yeah. I mean, it is like, I think, I mean, I'll probably look back on this recording in a few years' time and think what a time it was versus, like where we'll be and where we're looking at now, because you're right, we're seeing, these releases of new models. I mean, I at the Google Summit, one of the guys said, the way that it's working at the moment is like, imagine you need to type an essay and type it as fast as possible with no opportunity to do backspace. This is kind of like how these models are working now, right? So there's a lot of, it's still doing so well. So you think about the opportunities for optimization. And I mean, I must say I was a little surprised that Chat GPT 4.0 was not 5, right? I mean, that was interesting. I don't think maybe, what I don't know, any intuitions on that? What do you think?
I don't think, I'm not quite sure.
I think it's like, I just thought it was interesting because I listen to, I guess, a lot of podcasts with Sam Altman and the guys that are working in this space, and it's really interesting to hear them talk about it. And I guess I feel like Sam's kind of wound back his projections a little bit, just like, I think they're kind of hitting that, maybe running out of data, maybe realizing, they're trying to put all these controls on the models and do all those sorts of things. And, I think it's going to be interesting. I mean, back to my original question about like, well, we'll see. I guess this is going to be the holy grail. Our transformers are going to be the holy grail. It seems maybe, but everyone said the same about about CNNs too for computer vision, and we're using different types of CNNs even to do language stuff as well, right? So it was kind of. I remember talking to one of my friends who actually probably one of the best engineers I'd worked with back in UNSW, and I was trying to poach him to bring him across to the business, right, to work at Tiliter. I think he was working for NAB at the time, actually. But I was talking to him about CNNs, and he says, mate, transformers, just give me a transformer, I can do anything. This was like maybe 5 years ago now. So he was, this is when the academic space has started to do this, and we didn't really see this. He's like, transformers going to be the way, and here we are. So I guess the academic space has kind of been thinking that a little bit as well, right? So it's not just, not just I guess, seeing the breakthroughs in what the technology can do, but I'd say it seems like, is that what you would, I guess you do a lot of research on papers and that sort of thing as well. Like, is that the general feeling at the moment? Like, it's kind of, I guess, that link, to talk a little bit about that. I remember reading a paper, I think it was maybe 3 or 4 years ago, about the semantic kind of component of the LLM, right? And how this can help vision. This is one of the topics we're talking about, right? How the semantic kind of understanding of the world can help you do vision, where CNNs don't have that, right?
Yeah, actually, for the transformer, I think first thing, it's very, very powerful, and the second thing, it's very costly, very slow.
Yes, yeah.
So at this moment, I think that's the major headache for applying a transformer in the real projects.
Yeah, definitely. I mean, and that's what, to touch on that, I guess, like looking at, where we are in terms of that space and the opportunities, like, I guess, how do you, I guess, see, and that's something we're looking at, how can we use these technologies and the ability to do what we're looking at is kind of how to do POCs quickly, right? And prove the concept and what these things can do. I mean, going back to you talked a little bit about, I guess, joining the old and the new with computer vision of the old and the new. Like, do you have any sort of thoughts on that, theories on that, about how that's going to come together?
Yeah, my thoughts regarding the new model is a little bit different. I think on one hand, we have the very state of art models. On the other hand, when you look at how the model was trained, it was trained on internet scale, very huge data set. So if we don't have those data set, we cannot achieve anything.
Yeah, that's the problem, right? This is the challenge, right? So how do you do it? That's the question, right?
There are several things we can learn from there. First thing is we need to think about how those models was trained, and if we rethink about the computer vision problem, and just for a moment we just forget about all the modeling techniques and transformer, we just put that aside and think about the computer vision. Actually, it's a very challenging machine learning problem compared to the tabular challenge.
Yes.
Because the computer vision is normally it's very high dimensional. For example, if we have the 2 to 4 times 2 to 4 image with 3 channels, the number of dimensions would be 140,000.
Yeah.
So for the high dimensional data, it's the biggest challenge is machine learning model is very struggling to find the similarity between the data points. So with the traditional computer vision technology, we normally augment the data with some standard functions like alter the brightness, change the contrast, and shift and zoom in, zoom out, do a random cut or something. But that kind of technique can only jitter the data around the original places.
Yes.
And if we just train the model based on those data set, normally we'll see that the model performance can reach certain level and no longer can improve. That's because the model is very difficult to find the pattern, the connection between the training set and the test set. So each of the dots are isolated. So
yeah, and it's interesting. This is a point. It's fascinating because I've been thinking about this as well. Like, obviously seeing the the question is, are they, and I would love to know this. I mean, maybe we'll find out soon. Maybe, I don't know, we maybe look it up after, but like, I don't think it's publicly available really. How are they actually dealing with the image input, right? This is important because, I guess, like you said, it's not computationally efficient to deal with pixel by pixel data, not at all, like really not. You can't do it like at the moment. Like, and I think, I mean, obviously this idea of, I mean, I think, you know, to give an idea of where OpenAI said it, you know, I think, you know, what was the quote, Sam Altman saying, oh, if we spend 100 billion trying to develop AGI, it's worth it. You know, it's like, okay, that's fair enough. But when we look at the industry application, it's probably, they're on a different sort of wavelength, right? And then it's like, well, is everybody going to be pushing their model to that data and it's doing pixel by pixel? I mean, it's yet to be seen. Is there a CNN in the front end of these models is a question as well, right? And are you doing those sorts of things? Because I guess if we go back to, you know, I mean, the original foundations of the CNN model framework, it was actually based on, you know, biology, right? Essentially a biology solution to that problem, which was having kind of these filters and you know, there's a couple, I've seen a few good animations on the internet about, you know, how you can think about it conceptually, kind of like cutting up images and looking for features and these sorts of things. But with images, you kind of need to do this in a sense. So it's interesting thinking about, I guess, the semantic part, which is like, okay, if I know the concept of red in words and the concept of a table in words, okay, that's good. Maybe I don't need to learn as much about the vision world, but how do you get the data in? I mean, this is something that's in the research space at the moment, but my intuition, probably like yours, is telling me I don't think it's going to be easy to solve that problem and say, you know, deploy things on the edge and this sort of thing. And this is a whole other topic, right? About what does the compute look like for these things moving forward? You know, data. I mean, as we're starting to look at industry applications for these things, it's like, is everybody happy with their data going to OpenAI and even Google to an extent, right? Like, I think, you know, Microsoft, anyone who's in that space. So how do you know, there's kind of, everyone's kind of moving at the moment and sort of embracing and moving quickly. But I think it's just kind of like a bit of a frenzy at the moment. I don't think we've actually really thought out, okay, what does the compute landscape look like in 10 years with these models, and what R&D are we doing around, you know, how to do this efficiently? Right. It's a fascinating, there's a lot of facets to it, right? So I guess, yeah, I mean, what are your thoughts on that, on the compute space?
Yeah, I think this is a good question. Actually, I think the latest development of the generative AI and other technology, it has two sides. On one hand, it gives us more power to do things. On the other hand, it raises the bar very high. And also the latest technology is very approachable to the end client. So for the AI practitioner, the phrase
yeah, that's right. It's interesting. The example I always use for that, and we have the same issue in cameras, right? The iPhone, the camera on the iPhone is so good, right? And people don't realize how much, you know, R&D, and we take it for granted, right? You take out your phone and you're like, oh, yeah, you know, you can do all these things, background subtraction, and you know, I'm always using the example of like the Snapchat filter, right? Where it's like you can do these amazing things, and you know, you've got this kind of amazing ecosystem that's really had billions of dollars invested into it, right? So to go but it's not suitable for every application, right? So then, and the camera, right? It's quite expensive. One of the most expensive parts of the phone, right, is the camera. So then you think, oh, well, no, you can't just go use that elsewhere. Okay, what's the industrial solution then? Well, that's actually a very open, right? Either there's nothing, or it's very sparse, or it's very expensive. So yeah, it's a bit interesting in that sense, but I guess there's opportunities. But I would say, I mean, my feeling at the moment, like where we're thinking with Tiliter at the moment, is it's a little too early to like go and say, well, I'm going to go and innovate around making an LLM lighter, for example, and maybe try to get some value out of that. Or I'm going to go and, you know, I mean, I've heard about, you know, quite a few. I guess there's a lot you could probably do at the, you know, low level of compute to optimize for these things, and you know, maybe, you know, you're able to do maybe in a few years' time we can actually run GPT-4o on a chip, you know, maybe. But do you want to invest in that now? I think it's too early, right? Because there's still so much going into the model development and we saw this with the TPU, right? You know, we used the Google TPU, the Edge Coral TPU. You know, I hate to say, but at the moment that's kind of old news now. Like it came on the market and it went because like I mean, we still use it for our application, right? But the model frameworks moved on so quickly from that, and that was in the CNN space, let alone in this space where it's like exploding, right? So yeah, it's such an early time, and as you said, like as AI practitioners, we're kind of I feel a little bit, and it was interesting. I'm hearing a lot of people talk about this, but it's sort of kind of just watching the space and kind of being excited. But as you said, it's kind of hard to make a dent in it because there's so much investment going into you know the next gen and like I said, I mean I could be wrong, but I think it would be a little foolish to dive into one direction too hard right now. Is that you know is that what's your feeling on that?
Yeah, I don't think we can wait. Yeah, because we cannot stop our career until something happens.
True. True. I guess it's like choosing directions, strategic directions around innovation
Yeah.
is more like, you know, for me, you're thinking about Tiliter and where we're headed. Like there was a time where, for example, we had a product called Deploy, which was basically a platform to deploy models and essentially products on the edge, right? Using the edge tools. And that was a pretty big play for us,
Yeah.
right? We in hindsight, we probably didn't have the capital to do it, right? We probably bit off too much right there. But and we kind of learned the lesson of that. But I would say at the same time, if we had the capital for it, we probably could have went pretty hard at it. But now I would say it's like it's pretty hard to go. I mean, maybe if you've got the right amount of capital, you can go after those areas. But I think, I guess, you know, just for me, looking at well, where are we focusing our time and what I'm thinking about, and maybe you're thinking about it differently, but what I'm thinking about is all the opportunity in the wake of the investment and the model development, right? I mean, realistically, I mean, I think about, and that's why I'd be interested to know how these things kind of work together, because I guess GPT, let's say 3.5, for example, we did some prototyping. I talked to you about this last time, right? We did some prototyping with GPT-4 and the vision model, right? And it was like, we still kind of outperformed it, you know, because it's, you know, there's areas where it can't do well. But I would say to see what it could do with no training was pretty mind blowing and pretty groundbreaking, you know, egg crack kind of moment. Like I said, 3.5 at least publicly can't do vision, but what if it could? You know, could we use that to do some of these things and sort of looking for those opportunities where it's like, well, some of those problems that we got approached about, you know, maybe at a trade show or whatever that we didn't solve in the past, you know, because we didn't want to train a model. Because like you said, the thing is, especially in the vision space and this data space, and we can touch a little bit more on that, like it's hard to do, right? It's hard to get enough data to do all this sort of, you know, if you want to train a specific model, even doing transfer learning to an extent, you've got to be really careful about how you do it, right? But some of the areas where we may have said, there's just no point in training a model, maybe we can, you know, approach some of those applications. That's kind of what we're looking at now, right? So, yeah, but is that you're saying no? We should go in and what I guess strategically, what are your thoughts on that space?
Yeah, actually, the information is very yeah, make a lot of sense. Actually, we should review the OpenAI and our policy in the industry leader. And both of our partners and also our competitor.
Yeah, that's right. Yeah, yeah.
It's something we should evaluate how we can benefit from them.
Yes, yes.
So we should view from a critic point of view to see what's the problem of that service.
Yeah.
Only number the chat so expensive, not easy to extend, easy to adapt to the domain.
Yes. Yeah.
That's our strength, our opportunity.
Yeah, that's right. And it's interesting. Yeah, there's a lot that falls out from that, right? I think, yes, I agree. I think, and that was the thing initially when we started doing the experimentation with the vision stuff. I said, well, to the guys, yeah, this is. It might not be now, but you know, in a few years' time, you know, it may be our competitor and completely make us redundant. And we said this before, right? If you were a chat bot startup in the last couple of years, you're gone, right? Like pretty much. I mean, there was actually a couple of there was a startup in the Europe that we went through a cohort with, and they had a good exit. They got acquired, and you know, it was a bit of a journey for them. They were in it for quite a while. And I must say, before that, I was very focused on the vision space, so I wasn't really at depth in the LLM space. And I would say even now, it's not my area of strength. My area of strength is certainly vision. But it was interesting because the timing for them was so right, because if they had have waited a little bit longer, like maybe I think it was maybe even 2 more years, I would say, they were toast, because there's just I think what the breakthroughs and, these larger models that have so much data, you're not gonna it's gonna be difficult to compete with that, right? Unless you have, some breakthrough strategy. I mean, I would say, interestingly, when we first started, we kind of, I mean, everyone was telling us that too around vision, with fresh produce. So that's been our bread and butter for the last, few years. But everyone was saying that to us too. But we found some innovation patterns around how to get this working on small sets of data. I mean, you work with us, you see some of the simulation. And we're kind of probably hitting the limit of that now, as we discussed, right? We're probably capping out, but we saw really, like, incredible kind of scalability that we could generate from that. And nobody was thinking about that back then, because everyone was like, wow, you can't, how are you going to compete with, this OEM and that retail? They've got millions of images, but it caused us to innovate. So it's possible that, there could be some innovations that people aren't thinking about, but the text is different. Like you said, text is different. I do think, right? It's not as, and it seems to be, I guess, generally, as from my understanding, I mean, maybe you can elaborate if you know more, but I would say at the moment, training is more or less unsupervised, and only, using reinforcement learning on the back end to get it to where you want it to go. Is it working like that for vision? I haven't seen, I haven't, we tried a little bit of this back a while ago, but I mean, what's your latest in that space? Have you, unsupervised learning is kind of also the holy grail for vision. Is it working like this now?
Yeah, I think for very large vision model and large language model, they really work like that. They call it self-supervised.
Self-supervised.
Yeah,
Mm.
maybe don't think that's suitable for us, because to doing that would really cost a lot.
Yeah.
Yeah, and also it's really bottom up.
Yeah. Yeah.
I think we can learn something from their practice. So even if with small data set, we can still see some significant enhancements.
Yeah. And that's, I guess, let's talk a little bit, I guess, now about like some of the specifics on that, because I think that's where we had some good, fruitful work together, and it was really, really exciting. I think, was really great having you with us, and especially, I guess, a third party view coming in, seeing what we're doing, bringing some of that new thinking in as well, innovating around some of the technology we had. Like, and one of the things we worked on, right, was certainly this transfer learning topic. I feel like that is important here, but actually, like you said, it's not really ready yet. I think the Google Summit, they released that you're able to do this for some of the Gemini models. Um, Microsoft is still on the cusp, I think, at the moment, and it's kind of, they got a bit of barrier there. But I guess, do you feel like I do, that that's going to be important for getting the most out of these things, like some of the transfer learning topics we've been touching on, how to do that well? Let's talk about that a little bit. What are your thoughts on this space?
Yeah, I mean, transfer learning based on the very cheap model.
Yeah. How do we, do you think, I mean, that would be to me, in a sense, like, I mean, conceptually, the way forward, in a sense, right? You would think, I mean, we're going to try this soon. So I don't know. What are your thoughts?
I think it would be harder for OpenAI and Google to do that.
Yeah.
Because if they offer the transfer learning by themselves, they may do how to manage maybe an algorithm or something.
Model.
Yeah, and it's
Yeah, that's right.
quite human work.
Yeah.
It's they go for us.
Yes.
Not being able, of course.
So the question is, how do we bridge that gap in the short term? That's probably the issue at the moment, right? What are your thoughts on that?
There are several things we can try. For example, we can pre-train the model already train our very huge data market and a very good performance. Do some transfer learning, to adapt to our domain. That's one thing.
Yeah.
And there's also some other thing we can try. For example, there's actually a very huge web scale open data set. It has 5.8 pairs, because I call it hearing pairs of text and image.
Mm-hmm.
For example, if you want to get all the image related to the Granny Smith, you can just search by Granny Smith.
Mm-hmm. Mm-hmm.
Get all the image on the website.
Yep. Yep. Yep.
And then there you can just put those images in your
Yes.
website, and all of a sudden you get very high quality.
Yeah. So, and that's because I guess it's one of the things we talked about, and I think it's still the case. I feel, I mean, I know, say, I mean, when we started, I think it's ImageNet now 21K, right? It was ImageNet 1K when we started. So now you've got this much larger image data, and there's a lot of other, there's so many data sets out there now, but that's an important thing, right? Having, if you're thinking about transfer learning, having a good feature extractor, right? So that you can actually then tailor that for your application. And that's, you know, some of the work that we did, right? Whereas, like, okay, you have a good base model and you're able to kind of tailor it a little bit. But you're right, I guess, and this is, it's funny to think about, yeah, we're facing some of these challenges now with some of the things that we're doing around how to optimize hosting. And okay, do you want to sort of tailor a little bit for this guy or that guy, or, you know, this person over here, you know, or you want this one model to rule them all. But getting that one model to rule them all is, and that's where it's going to be interesting. And that I think you're hitting on, it's like, that's going to be the big challenge, I think, for these larger models, right? Especially, I guess, solving, and it's always the 80-20, right? You know, you get the 80%. It works so well. And to get the 20%, well, at the moment, if it's not doing that 20%, you can't close that gap. There's nothing you can do. And as you said, that gap between, well, what that can do, and if you want to start here, well, we haven't actually made that much improvement here, right? So it's interesting in that sense, right? Yeah. So there's still a bit of, this is good, because I think it's, you know, it's making me think a little more about, like, there's still quite a bit of time. This is, I guess, the challenge, right? Everyone sort of is thinking about, we can do so much, but it's like, I mean, for those who've worked in the industrial space and talked about actually industrializing these things, it's a different ballgame, right? Because, you know, I think, again, and we get a different perception from the consumer view, where it's like, okay, like I always, Snapchat's such a good example. So like the things you can do, like, you know, with just the face filters and stuff like this. And it's like, but it gives you a false perception, because it's like, well, if that face filter fails, you don't care. You laugh it off and you try again, right? Whereas in an industrial setting, if it fails, well, maybe you don't have a product, right? Maybe in certain applications, it's catastrophic, you know? So vision, unfortunately, is kind of, you know, and still has, I must say, I think, you know, and it's not the fault of the model, right? Maybe it's the data, but I would say CNN still had a way to go, right? To get to that sort of point, right? Yeah. And so it was, and you know, I guess, I mean, what's your feeling on models versus data?
Yeah, good question. Actually, previously, when we talk about the machine learning performance, we are thinking about the model. If we just apply the cutting edge model, it will be good. But actually, not like that. There's one of the recent firm called data-centric machine learning.
Yes.
That means if you want to get the performance, actually, you need to look at your data to see whether it's ready. Yeah, I think it's a good approach. And if we rethink about why the other models can achieve very good performance, we can. Yeah, the secret in data.
Yeah, that's right. Yeah, definitely. And it's like, yeah, you know, I think particularly for practitioners like us who are dealing with sort of, you know, niche spaces often, you can, yeah, certainly have that false perception. I mean, for us, you know, particularly in our production environments, you know, we're using, you know, arguably kind of older models, right? But, you know, they're constrained compute, and they do what they need to do. And I would say only recently, you know, have we just started to tip the point of where, okay, the data is starting to outstrip the model. But before that, it was clearly clean the data up. You know, you have mislabeled categories and all that sort of stuff. And you might, I guess, get into a false, especially if you're not thinking about it and you haven't got your data structured correctly. You know, this idea of, say, I mean, we do something like, for example, and I was interested to hear your thoughts on this, because and whether or not it was something you'd seen, and what's standard, because in the academic space, for example, you have test, validation, and training, right? where's the test data from? It's from your, usually from well, in the academic space, it's normally from the same distribution as your test and validation. For us, we use a more broad, right? Because we kind of want to go out and build a model, and it's easy to say, well, okay, I'm going to go train. We actually call it a target set, right? So you might say, well, you want to go train on that data. Yeah, but it gives you false hope. That's the problem with it, right? I feel like if you're training on that, I'm constantly talking to the team about this, so I'm keen to hear your thoughts. If you're training on that data, yeah, it'll help you, but you're not really improving your fundamentals. I think you haven't actually improved your fundamental model, and you'll end up, I've seen, time and time again, ending up in a trap where you deliver really good performance because you train on that, but you can't scale it. And so, especially from a customer perception, all of a sudden you're out of whack. Whereas we sometimes move a little bit slower with respect to delivering performance. Like we'll edge it up, but we really try and push the team to stay away from. It's always tempting to go and train on the field data, right? Because you get the good numbers, right? But it's not scalable because the field data is always biased. It always has caveats to it, and it's maybe, I don't know. There's, I mean, I don't know. I mean, again, I'll let you talk in a minute. I'm trying to give the context here, but like I've also people talking about, well, continuously training, but it's like I feel like that's also fruitless as well because you kind of, well, yeah, it never ends, right? So the cost never dies. Are you actually building a model that actually works? And I think this is clearly what OpenAI has done well, right? They've kind of, and they talk about this, right? It's all about the data centric approach. Get that right, and then you have something that's great. Whereas if you and the big guys also talking about this as well, I've got all this data, even in the tech space, I've got all this text data. Let me go train on that, and then I get something good. No, that's not how it works, right? And what are your thoughts on that? I mean, having worked a little bit with us, and I guess that idea of papers as well, because you get this in papers, right? Where it's like, oh, we increase the model by this and this much and that much. It's like, well, it gives you this false sense of, well, that's how I'm going to do it in an industrial setting, right? But we've seen, our approach is not to do that, and it's kind of proven itself so far, but it's always changing. So yeah, what are your thoughts on that?
Yeah, yeah, that's why I actually very enjoy working with Tiliter, because if you think about considerations, especially classification of the images, is quite simple, right?
Mm-hmm.
If you apply the theory to the real world, you'll find numerous issues, model challenge, and a very long list of things to.
Yeah, that's right. That's right. And I would say, like, my question would be, like, in your experience around applying these things, because I would say I feel like our approach to that has been quite different to most. But we've also been looking at our space, and trying to sort of look at, and obviously, especially in industry, people don't talk about how they do it because it becomes IP. What's your feeling on that front? Like, I guess in terms of how people are approaching it, and are they trying to build specific models, or are they trying to build the general model that's going to scale?
So what do you mean by
Well, so for us, for example, I mean, we've got it. We might have a customer, for example, customers now that we a simple way to improve the performance would be to train on that data, right? But the problem is, it doesn't. For me, it's like, well, that's kind of a false economy because if we need to train on that data, that's test data for us. Essentially, we call it target data, but we should call it test. And speak to some of the engineers about it. So, why do we need validation tests and whatever? Because we still, use validation, train, validation, and test, right, just to validate the model. But then our benchmark is against field data, right? And there's all kinds of problems with that, as you said. Are the labels good? How do you know the labels are good from your field data, right? Because you don't know. So and also, like, I guess if you're how exhaustive is your field data as well? A good example for us is lychees. I always use the example like lychees. Well, how often do people buy lychees? Certainly not as much as they buy bananas. But you're thinking about that, well, okay, and I've got good performance on bananas, but how are my lychees doing and all these sort of things? So there's a whole raft of things. But I guess it's like, well, yeah, our philosophy is and we probably leave a little bit of performance on the table at times. But this is another big thing that we've learned over the years about delivering this technology. The customer experience, or the experience using the technology when it comes to AI, is super important, in the sense that let's say I train on that data and I give them great performance for a month until the new category comes in, right? And then I have to train again, and they change the sticker, and they move the checkout, and they do all this, right? And then all of a sudden I never stop training, and they're always coming back to me saying, this doesn't work, that doesn't work, this really worked before and that doesn't work now. Whereas, like, I guess what we've done is say, well, leave that data alone. Try to leave that alone as much as possible, and we touch it from time to time. We call it sweetening the model, because at times it's like you want to give that performance, and there might be a project where you really want to push it, but I know we're kind of dealing with the devil there, you might say, where it's like we're kind of doing something that we shouldn't do, because eventually what's going to happen is something's going to happen, right? Because especially if you're training one model, it's like, well, this customer comes in, they've got this data, and now it's kind of this, I think about it like that game where it's like you're trying to balance balls on the this is what training a machine learning model is right? It's like, if you go too far this way, it's like all the balls go everywhere. So you're trying to like balance this thing, and that's where you end up with field data training. It's seriously, it's like you end up in this kind of like weird mode where you're trying to optimize and the balls are going everywhere. And when you come down to, the amount of categories that we have, you can't manage this. It's very difficult, because again, you've only got, this customer, well, maybe they purchase lychees 10 times more than that customer. Well, what happens to your model now? Because it's a slightly different environment. So it's interesting, because I mean, that's been I feel like it's been something, like I said, where we've often also left performance on the table at times. And, the team will push and say, oh, can't we just translate with guys? We're kind of giving falsehood. And going back to my original point was, well, then I have to go back to the customer and tell them, well, remember how good your model worked like last month? Well, it's not working that well now because of X, Y, Z. And I don't think that doesn't make a product. You can't have a product like this, right? Yeah. So, is that, I guess, what do you see in industry in that sense? Is it similar, or people doing different things? What are your thoughts?
Well, actually, every business do things differently, but all the challenges that I mentioned, I'm not quite sure if it's doable, but from one point of view, I feel like maybe we should build the general purpose model, and use the factor to fit different needs of different types.
Yes.
Then we need to use the data-centric method to manage the difference between the different kinds.
Yes. Yeah.
The model always it's different. The given kinds. We need to find out what really happened.
And that's right. And I think from a product point of view, that's what I always thought. From a product point of view, that's kind of, it's not acceptable, right? And it's been one of the things that's it's been, we've got, we've I would say, certainly been one of, if not, the pioneer in this space. Certainly in Australia, but globally, certainly been one of the pioneers in this space. And I feel like, for our particular area, and I feel like sometimes we do ourselves more damage, by kind of, again, it's this false economy training. And like you said, I mean, our approach has certainly always been try to build that one model to rule them all and scale that. It's difficult, right? I mean, that's what I say. I mean, it was so, I was really excited to hear, some of the first discussions that Altman had about, the way that they do it. And, I mean, they're solving the world's problems around text and all this sort of stuff, but it's like, we're focused on fresh produce, but it's kind of like, it's the same concepts, right? I mean, going back to your point before about the concepts, all of the concepts still apply. I think that's one of the things, and we might have touched on it before, like about sometimes people think that the models are these magic boxes, right? And it's not the case, right? It's really not. It's like you get out what you put in, and if you don't do it right, it's not going to work, right? So,
yeah, what I'm thinking is maybe we can use the fine-tuned version to fit which client. And after we satisfy with the performance of the transfer model, we can extract the knowledge into escalate the knowledge into the baseline model.
Yeah. We'll see. There's plenty of work ahead of us. So, yeah. Look, coming to time. I mean, I really thanks for your time, mate. Like, it's been good. I guess we'll see how it turns out, in the final form, and I'll do a bit of editing and see how it comes together. But a couple of questions I wanted to round off with, and we'll see how it turns out. Maybe we can talk again in a few months' time. Actually, one of the things before we end off is you said you were doing a bit of experiment in this space as well. Like, I mean, what is some of your findings? I want to give you opportunity to share some of the things that you've been looking at. I think you were a little bit inspired from, what we were doing, and it push you in a direction of like, hey, these are experiments that we can do, right? Like, what have you seen in that space? Anything you can share?
Yeah, we do live on the experiment. Something is related to the calculation.
Yeah.
For example, I train several well models like efficient math.
Yep.
Not very huge of that. And I noticed that the performance was not very good.
Mm-hmm.
Yeah. And if I do the transfer learning, I free up the populate 10% layers. And then training model is very fast and it can achieve very good.
Mm-hmm. Mm-hmm.
That's why I suggest to consider use the transfer learning.
Yeah. Makes sense. Cool. Well, yeah, I guess so. Two questions I had was, I mean, you're AI practitioner now. I mean, it's arguably, honestly, as an engineer, it's the hottest space to be in a weird way, because like we said before, as a practitioner, we're also like, oh, there's so much happening. Like, where to place ourselves, right? But I mean, what would be your advice, I guess, to somebody, in their career, getting into this space, from your experience? What would be your advice to up and coming people who want to work in the space?
Well, actually, just very recently, I saw a report. It reached that on the number of leading profiles with AI skills has increased 140% in the last year. And among the country, the companies investing in AI only increased by 40%. Yeah, that's very revolutionary.
Interesting. Yeah.
That means the next type of AI development would be a ground. Yeah, not much up down. It's ground down.
Well, what do you mean by that? Maybe, yeah, it's interesting. I think I can almost grasp what you're saying, but maybe, yeah, explore it a little bit more. What do you mean by that?
Yeah, I believe on one hand, we'll see that the corporate competition for AI, machine learning stuff, maybe not enough.
Yeah.
It would be a very crowded market.
Yes.
On the other hand, we'll see a lot of startups like other unicorns.
Yeah.
Will grow everywhere.
Yeah. I think you're right. It's an interesting point, because I think certainly, and that's even our view, right? And we're in the space, is that the next wave of AI innovation, and I'm going to think about this. This is a really good point. The next, I'm going to sleep on it. The next wave of innovation, I'm thinking in my mind, this is not going to come from startups. It's going to be taking the tools, and this might be right. We're going to see, right? And like you say, well, AI practitioners, I think from the corporate view, there's so much opportunity now created in the short term around, being just taking off the shelf stuff. That there may be less investment, as you're saying. It makes sense. There's potentially less investment in internal projects around AI, whereas before it was kind of everyone was building their own thing, but now it's like, well, what can we do with the off-the-shelf tools? So yeah, you're right. It may be a challenging time. So I guess, what would you, to extend on that, like, again, for I mean, guys like yourself and people who are up and coming in that space, where are you focusing to kind of make sure that you're in the right space? I mean, for me, I would say, like, I've always loved you've got to have the fundamentals, right? The data, the model. It's like, you kind of get, you may struggle in sort of delivering high quality products if you really don't understand those fundamentals. That would be my thought. What's your thoughts on this front?
Yeah, I think for other AI engineers, myself, I think AI would be the same. Just be curious, be open-minded to learn new things, and be patient.
Yeah. Don't try to go too fast, right? I think that's what everyone's doing at the moment. And just finally, you said you've got some, I guess, so you write some blogs, you do some research as well. So yeah, where can we find that? I guess I'll put it in, if we post up, I'll put it in the video as well in the description. How can people stay up to date with what you're doing?
Please follow me on LinkedIn. They can be searched by just Kelvin Lu. Yeah, my boss will be very happy if we can have some business opportunity. Can help our clients to be saving with a lot of money, a lot of time. Yeah, this is what we can do. And also personally, I do a lot of research and post some technical blogs regarding general machine learning practitioners and large language model generative AI. Yeah, yeah, and happy to connect with everyone. We inspire each other.
Yep. Great. Yeah, mate. And thanks for your time. Definitely we'll share that. And yeah, definitely would vouch for your skills and Intelia's skills in the space. It's been really great. And looking forward to staying connected, maybe having another conversation in the future. Thanks,
Yeah,
mate.
yeah, absolutely.
All right. Cool.